Hello everyone, welcome back to my YouTube channel. I'm really happy to see you here. So let's begin our learning journey together. In this class, we are going to discuss exercise 1.1 from chapter 1. I will explain a few problems and also two examples from the textbook which are in page number 5 so that you understand the concepts clearly. Let us start with the very first problem. I will explain step by step, so make sure you follow carefully. So if you are not familiar with the what Euclid algorithm is, so check out my previous videos about explanation on Euclid's algorithm to understand better. So in the exercise 1.1, which is in chapter 1, the very first question is use Euclid's algorithm to find the HCF of 900 and 270. So let me recall you what Euclid's algorithm is, how we move step by step. So first we start dividing the larger number by the smaller number. Then take the remainder. If it is not 0, divide the previous divisor by this remainder and continue the process until the remainder becomes 0. And the last non-zero divisor is the HCF of given numbers. So now in the first problem, what are the given numbers? 900 and 270. So according to Euclid's algorithm, what is the equation of Euclid's algorithm? Just recall quickly. Yes, Euclid's algorithm is A equals to BQ plus R. So here we need to find the HCF of 900 and 270. So we move on by dividing the larger number with the smaller number. So among these two, quickly say which is the larger number? 900, right? So A will be the 900 equals to B. B will be the smaller number which is 270. Now quotient is something that it is a number with which we multiply to get this A. Okay. So take 270 table and see whether we get 900 or not. So 270 into 1 is 270. 270 into 2 is 540, right? Next, 270 into 3 is 810. So we are near to 900. So 27 into 3 is how much? 800. But the number we need is 900. So we'll get here remainder. What will be the remainder? So 800 minus 900. How much? 90. So 90 is the remainder in the first step. Now in the next step, as we did not get remainder 0, in the next step we will take divisor, that is 270 equals to, and divide it by the remainder 90. Okay, so 90. Now here we'll take the number with which we'll multiply to get 270. So now the table we need to look at it is 90. So 90 into 1 is 90. 90 into 2 is how much? 180. 90 into 3 is 270. So we are getting the required number with 90 into 3 is 270. So what will be the remainder? 0. So as we are getting remainder is 0, This is the last step and we need to stop it by here. So what is the quotient here? 3. And what is the remainder? R equals to 0. So we need to find HCF, right? So what will be the HCF here? HCF is 90. So as remainder is 0, so last divisor is 90. With the divisor 90, we are getting remainder as 0. So HCF here is 90. Okay. So let me explain you once again. See, we have two numbers, 900 and 270. What is the Euclid's algorithm? Euclid's algorithm is A equals to BQ plus R. So A is the largest number among the two numbers given, which is 900 is the largest number. So B is the other number, 270. Now we need to find quotient and remainder. So with what number we multiply to get 900? So write write on 270 table and see where you will get 900. So 270 into 3 will get 810. Okay. So we are nearer to 900. So what will be the remainder? 900 minus 810 is 90. So in the first step, we got remainder as 90. So as we did not get remainder is 0, we'll move to next step. Now in the next step, we'll take divisor, that is 270 equals to remainder in the first step, which is 90. Now multiply with some number to get 270. 90 into 3 is 270. So the number which we have, we are getting the required number if we multiply 90 into 3. So what will be the remainder? 0. So quotient is 3. And what is the remainder? Remainder is 0. And what will be the HCF? HCF is in the last step. What is the divisor? Divisor is 90. That is HCF of the given problem. So by Euclid's algorithm, we found that HCF is 90 of the given numbers 900 and 270. Okay. Let's move on to the second problem. Notice the method is similar, but the numbers are different here. Okay. So what are the given numbers? Given numbers are 196 and 38220. So what is the equation of Euclid's algorithm? A equals to BQ plus R. So in the place of A, we'll take the highest number among the two numbers. So what is the highest number? 38220. So B is the remaining number, which is 196. So according to Euclid's division algorithm, we divide the larger number by the smaller number and we keep dividing till we get remainder equals to 0. So now we divide 38220 and 196. So with what number we multiply to get 38220? So write 196 table in your rough sheets and keep on repeating till you get the number. So 196 into 195 will get 38220. So as we are getting the required number which we need, so the remainder will be 0. Now tell me what will be the Q and R in this question? Okay. So right, Q is 195 and R is 0. Now quickly say me what will be the HCF. Okay. So HCF is the divisor. So in the first step, what is the divisor? 196. So 196 is the HCF of given two numbers 196 and 38220. So this is the second problem. We are done with this. Now similarly try this third problem in your exercise 1.1 in the very first question. So finally let's solve one more problem from this exercise to strengthen your understanding. Keep on practicing along with me. So you can test that did you understand properly or not. So what we need to do, first we need to write what is Euclid's algorithm is. So according to Euclid's algorithm, a equals to bq plus r, right? So what will be the a? A is the highest number among the two given numbers. So what is the highest number among the given two numbers? 2030 is the highest number. So the remaining number is B, that is 1651. Now we need to multiply with the number to get 2030. Now what is the divisor in the first step? That is 1651. In your rough sheets, write 1651 table. 1651 is 1651. 1651 into 2 is 3302. So here we are getting larger number, that is 3302. So we'll take a lesser number, that is 1651 into 1 is 1651. So 1651 into 1 is 1651. So what will be the remainder? 2031 minus 1651. So answer is 381. So in the first step 381 is your remainder. Now we did not get remainder 0. So we keep on repeating the steps till we get remainder equals to 0. Now in the next step we will take the divisor from the first step. What was the divisor in the first step? 1651. So 1651, and here the b value will be the remainder in the previous step, that is 381 into, now what is the divisor in the second step? 381. Now in your rough sheet go on writing 381 table till you get 1651 number. So 381 into 3 into 1 is 381. 381 into 2 is 762. Keep on writing. So 381 into 5 equals to 1965. So we are getting number greater than 1651. So we take 381 into 4, which is 1524. So what will be the remainder now? 1524 minus 1651. So what remainder you will get? 127. So in the next step remainder is 127. So here also you did not get remainder as 0. So again you will do one more step till you get remainder 0. In the next step, so what will be the a value here? The divisor in the previous step. What was the divisor? 381. So 381 equals to, what was the remainder in the previous step? That was 127. Now here the table we need to consider is 127. So 127 into, keep on try with the number till we get 381. Right? 127 table and see where you will get this 381. So 381 you will get 127 into 3. 127 into 3 is 381. So as we are getting the required number which we need, so the answer is 0, that is remainder is 0. So we will stop by here as we got remainder is 0. Now What is the quotient? Quotient is 127. And what is the remainder? Remainder is 0. Okay. Now, quickly tell me what will be the HCF of this problem. Okay. Can you quickly comment me what will be the HCF of this problem? So, comment down the answer. What is the HCF of this problem? So, in the next class, we'll see few examples which are in page number 5. So, that's all for today's class. We covered exercise 1.1 first question. I hope you understood the concepts clearly. Don't forget to practice more problems from your textbook. If you found this video helpful, please like, share and subscribe to the channel for more maths lessons. Thank you for watching and comment down the HCF of this problem. Bye bye.